Hello and welcome to MIT Sloan Alumni Online. Every month, MIT Sloan Alumni Online brings you the latest breaking news, cutting-edge research, groundbreaking ideas, and school updates from MIT Sloan faculty and alumni. Today, we're thrilled to have Professor Thomas Malone joining us. Professor Malone is the Patrick J. McGovern Professor of Management here at Sloan. He's also the founding director of the MIT Center for Collective Intelligence. He teaches classes on organizational design, information technology, and leadership. His research focuses on how work can be organized in new ways to take advantage of the possibilities provided by information technology. As you can see from this slide, Professor Malone's accomplishments are many. In 2004, he summarized 2 decades of his research in his book, The Future of Work. He has written over 100 articles, research papers, and book chapters. He is an inventor with 11 patents and the co-editor of several books. In 2012, he received an honorary doctorate from the University of Zurich. He holds a BA in Mathematical Sciences from Rice University, an MS in Engineering Economic Systems from Stanford University, and a PhD in Cognitive and Social Psychology from Stanford. Professor Malone, we are honored to have you here with us today. Thank you for joining us. I will now turn it over to you.
It's a great pleasure to be here. And what I'd like to talk about today is how to create more intelligent organizations. Now, to create more intelligent organizations, one of the first things we need to realize is that intelligence is not just something that happens inside individual brains. It also arises in groups of individuals. In fact, I define collective intelligence as groups of individuals acting collectively in ways that seem intelligent. Now, by that definition, collective intelligence has existed for a very long time. Armies, companies, countries, families, these are all examples of groups of people working together in ways that at least sometimes seem intelligent. But in the last few years, we've seen some very new kinds of collective intelligence enabled by new information technologies. Think of Google, for instance, where millions of people all over the world create web pages, link those web pages to each other, and then all that knowledge is harvested by the Google algorithms, so that when you type a question in the Google search bar, the answers you get often seem amazingly intelligent. Or think of Wikipedia, where thousands of people all over the world have collectively created a very large and amazingly high-quality intellectual product with almost no centralized control, and by the way, in most cases, without even being paid. So these early examples of information technology-enabled collective intelligence are not, I think, the end of the story. I think they're just barely the beginning. I think we're going to see many more examples of IT-enabled collective intelligence over the coming decades. And if we want to predict what's going to happen, especially if we want to be able to take advantage of what's going to happen, we need to understand those possibilities at a much deeper level than we do so far. That's our goal in the MIT Center for Collective Intelligence, and part of my goal with you all here today. One way of framing the core research question, which we use in the Center for Collective Intelligence, is this: how can people and computers be connected so that collectively they act more intelligently than any person, group, or computer has ever done before? Now, of course, that's a very big question. In some sense, it may never be completely answered. But what I'd like to do today is talk about 3 projects we're doing to help address parts of this big question. The first project I want to talk about is one about how to measure collective intelligence. If you think collective intelligence is important, as we certainly do, then it would be useful to have a way of measuring collective intelligence more precisely. So that's the subject of one of our projects, where we've applied the same statistical techniques used in individual intelligence tests to measure the intelligence of individual people, but we've used these techniques to measure the intelligence of groups. We found that just as with individuals, there's a single statistical factor for a group that helps predict how well a group will perform on a wide range of very different tasks. We also found that the group's collective intelligence, which is what we call this factor, that their collective intelligence is only moderately correlated with the average individual intelligence of the people in the group. So that means just having a bunch of smart people isn't enough to make a smart group. But that raises a very interesting question. If just having smart people isn't enough to make a smart group, what is? And in our research, we found at least 3 other factors that were significantly correlated with the collective intelligence of a group. The first was the average social perceptiveness, or what you might call social intelligence, of group members. We measured this with a test called reading the mind in the eyes, where people see pictures of other people's eyes and then try to guess what emotion the person in the picture is feeling. It turns out that when you've got a bunch of people in a group who are good at doing this, then the group on average is more collectively intelligent than when you don't. The second factor we found that was correlated with the group's collective intelligence was how equally people participated in conversation. So if you have 1 or 2 people who dominate the conversation, then on average the group is less collectively intelligent than when people participate more equally. And the third thing we found that was significantly correlated with the group's collective intelligence is the proportion of women in the group. More women is correlated with more intelligent groups. Now, interestingly, it turns out that this last factor is mostly explained statistically by the first one. In other words, it was already known before our research that women on average scored higher than men on this test of social perceptiveness. So one possible interpretation for our results is that what you need for a group to be collectively intelligent is to have enough people in the group who are high on this measure of social perceptiveness. And if you have that, then it may not matter very much whether those people are men or women. But if you know nothing about a person besides their gender, you're a little more likely to get this with a woman than with a man. Now, another interesting thing about this result is that it's not what would be typically expected by people who talk about gender diversity. I think most people who talk about that would expect that the most intelligent groups would be the ones that were half men and half women. But that's not what we found in our results. Here's a graph showing the collective intelligence of the groups as a function of the percentage of women in the groups. Now, there's probably a lot of noise in this data because you see the points are up and down a lot, but there seems to be a kind of underlying linear trend here. In other words, it seems that having more women may be better almost all the way up to all women. Certainly, the groups that are half men and half women were among the least or lowest scoring on collective intelligence, at least in our data here. Now, I think there are a number of things to consider about these results. One is that these experiments were done with groups of strangers, 2 to 5 people in the groups, people who'd never worked together and who had no particular skills for the tasks they were doing, no predefined roles. So they weren't typical of most of the groups in the real world. But I think these results at least have some intriguing implications for how we might think about creating more intelligent groups and perhaps even measuring the intelligence of real-world groups. I think one important clue to what's going on here comes from some later studies we did where we had some groups working together to take our test of collective intelligence face-to-face. And we had other groups working together to take the test online. In the online groups, people could only communicate by typing text messages to each other. But what we found, to our surprise, was that the social perceptiveness of the group members, as measured by this test for reading the mind and the eyes, that was an equally strong predictor of how collectively intelligent the groups would be in both face-to-face and online. In other words, in an online group where people couldn't even see each other's eyes, the groups that had more people who were good at reading emotions in eyes were also more collectively intelligent. Now, what I think that means is that even though this test of reading emotions in eyes was measuring one very specific skill, I think it must also be correlated with a much broader range of interpersonal skills, what you might call general social intelligence. And the people who are good at that must also be good at predicting what other people are thinking based on what they type, or predicting how people react based on what they type, and a very broad range of interpersonal skills. So I think one of the important implications of this is that interpersonal skills may be even more important than we think in the increasingly online organizations of the future. Here are a couple of other results from our work on these lines that you might be interested in. In one study, we looked at not gender diversity, but cognitive diversity or cognitive style diversity. So we defined cognitive style in terms of three basic types of cognitive style, what we called verbalizers, spatial visualizers, and object visualizers. Loosely speaking, those three cognitive styles are the types of thinking that are common in people who are liberal arts majors, visual arts majors, and engineering majors, respectively. So what we found here was that the most intelligent groups, most collectively intelligent groups, were the ones that had a moderate level of cognitive style diversity. In other words, if you had a group where everyone had the same cognitive style, that group wasn't as smart, perhaps because they didn't have enough people to deal with all the different kinds of problems, were skilled at dealing with all the different kinds of problems they might see. But also, if you had groups that were about evenly distributed among the three different cognitive styles, those groups weren't as collectively intelligent either, perhaps because they found it hard to even communicate with each other since they had such different cognitive styles. You might also be interested to know that we've done this collective intelligence test in different cultures. We've translated it into German and Japanese, given it to groups in those countries, and we found that in all three cultures, U.S., Germany, and Japan, we got a very similar result, that a single statistical factor predicts a wide range of a group's performance on a wide range of different tasks. Another obvious question is whether this test actually predicts performance of a group on a real-world task. One intriguing clue we have about that comes from a study in which we gave the test to teams that were already experienced in working together in the most popular online video game called League of Legends. And we found that, just as we had expected, the groups that were more collectively intelligent, according to our test, were also better players in this online video game. Now, that doesn't completely prove that this would be true for other kinds of groups, but I think it's at least an intriguing suggestion that this test could predict how well, say, a top management team or a board of directors might perform, how well a sales team might perform, how well various kinds of real-world groups would be able to do a wide range of different tasks. So what can we learn from all these experiments? I think there are at least two things that matter in creating smart groups. The first is how well the individuals in the group can perform the basic tasks that need to be done to perform what they need to do. That's kind of obvious, but I think the other thing that's critical is how well the individuals work together. Now, in the small groups like we studied in the experiments I've told you about so far, a key factor that determines how well individuals work together is just the interpersonal skills of the individuals. But as groups get larger and larger, an even more important factor often is how the organization itself is designed, how tasks are broken apart, how different kinds of groups are coordinated, what incentives are available to people, all those aspects of organizational design. And it also turns out that new information technologies can help create new kinds of organizational designs or make feasible organizational designs that would never have been possible before. So what I'd like to spend the rest of our time here talking about is how new IT can enable new organizational designs that can create smarter groups. The first thing I'd like to talk about there is a project we did where we were mapping what we called the genomes of collective intelligence. To do this, we collected examples of over 200 interesting cases of Internet-enabled collective intelligence, things like Wikipedia and Google and Innocentive and others. And when we analyzed these, we found that there were a small number of patterns, design patterns, that kept coming up over and over. We called these common design patterns genes, by analogy to biological genes. But if you don't like that analogy, you can just call them design patterns. We identified a starting set of about 17 of these genes or design patterns, the most important of which are shown here. Essentially, what this means is that any organization or any subpart of an organization, even any activity, has genes to determine what is being done, who is doing it, why they're doing it, and how they're doing it. And for the how genes, we have an even more elaborate set of possibilities based on whether whether the group is creating or deciding something, and whether the group members are doing different pieces that are more or less independent of each other or more or less interdependent on each other. We don't have enough time today to go through all these different genes, but just to give you a little sense of what we've done, I want to give you quick examples of two of these genes, what we call contests and hyper-specialization. So the contest gene is one where you have different people creating different items, different answers to a question, or different solutions to a problem, and where you only need one or a few of those items, which you can select as winners. For instance, there's a company called Innocentive that has a website where other companies or customers can post scientific and other problems, like how to synthesize a certain chemical compound. There are over 12 million scientists around the world who see the things that get posted on this website, including retired scientists, professors, contract researchers, students, and others. And when someone sees a problem they think they can solve, they can go to work on it. If they do, they can submit their solution, and then the winning solutions are chosen and can get awards of up to $100,000 or even more. So here's a way of solving problems by harnessing the collective intelligence of a much larger group of people all over the world. The other gene to talk about today is what we call hyper-specialization. That is, people working together, each doing different pieces of a bigger problem, but where the pieces are more specialized and smaller than is typical in today's jobs. Now, this kind of division of labor has been around for a long time, starting with division of labor in factories hundreds of years ago. But new information technologies now make it possible to divide work in much more fine-grained ways for knowledge work, not just physical work. And often that allows you to get global economies of scale for much more specialized pieces of an overall job or task. For instance, there's a software development platform called TopCoder, now a part of Wipro, with an online community of over 600,000 freelance programmers all over the world. TopCoder's customers ask for it to develop software systems But when Topcoder does that, they divide the task of developing software into much more fine-grained pieces than is typical in the software world. They might have some people doing requirement specifications, others doing architectural design, others doing user interface design or coding different modules, etc. And for each of these tasks, a group of freelance programmers competes in a kind of online contest to see who can do the task better. The ones who win gets monetary awards. And most interestingly for our purposes, different programmers often specialize in different kinds of tasks. There might be some people, for instance, who specialize only in debugging other people's code. Or there might be people who specialize only in doing user interface modules for iPhone applications. And by specializing in that way, people get very good at the specific kind of work they do. By letting people do that and letting people choose what they want to do, they often get much more efficient programming. Topcoder says, for instance, that they can often do software of equal quality to software developed in more conventional ways, but at as little as 1/4 of the cost. So those are both examples of genes that let us use IT to create new kinds of organizational designs. The last thing I'd like to talk about is a way of applying both of those genes and others to very big, hard, complicated problems. How can we do very large-scale collective problem solving? The approach I'm going to talk about is one that I think can be applied to many kinds of complicated problems, designing products, doing corporate strategic planning. But the problem we chose to focus on initially was a very complicated problem, and a problem that many people would say is one of the most important problems we humans face today. That is, what to do about global climate change. We've essentially crowdsourced that problem to a worldwide community. We've created an online platform called Climate CoLab and a community of over 90,000 people, including some of the world's leading experts on climate change, as well as business people, scientists, students, policymakers, NGO members, and many, many others from literally all over the world. Together, these people are developing and evaluating proposals for what to do about different aspects of the climate change problem, from how to generate electricity with fewer emissions to how to change people's attitudes about climate. Each of these proposals can include information about the proposer's ideas. One of my favorite proposals is this one. It was a grand prize winner a couple of years ago. It's a proposal for a low-cost device called Sunsalute. That's a rotating solar panel that rotates during the day to follow the sun across the sky. By rotating in that way, it generates about 30% more electricity than would be possible with a fixed solar panel. And what powers the rotation is gravity and dripping water. And as the water drips, it's filtered to make about 4 liters of clean drinking water per day. So this one low-cost device produces both electricity and clean drinking water, 2 critical needs for millions of people in the world. So this is an example of a technology or a technical proposal, but we also get proposals for many other kinds of actions we could take. Some are proposals for laws or regulatory actions that governments can make. Others are proposals for things that businesses can do or that individual consumers can do. A very wide range of different things come in. One thing that I think is particularly interesting about this proposal, and of many of the proposals we get, is that they come from unusual places. For instance, the creator of this proposal is shown here on the slide. Her name is Eden Full. She wasn't a professor at Stanford or MIT or any other leading climate research organization. She was a Princeton undergraduate who dropped out of Princeton to create a nonprofit that helped countries and others around the world manufacture and sell this Sunsalute device. So I think that's another important value of using contests and other crowd-based methods like this to get clever ideas, novel ideas from all kinds of unsuspected places. When you have a big problem, like the climate change problem or any of the other complicated problems we were talking about, you can't solve it all at once either. One thing you need to do is break the problem down into pieces. In the case of Climate Collab, we did that by breaking the problem down into a number of different, more specialized, in some cases you might even say hyper-specialized, contests about topics like generating electricity, reducing emissions from buildings or transportation, adapting to changes like rising sea level. Each of those are different specialized contests in which people submit proposals and winning proposals are selected. But just having good solutions for all the pieces also isn't enough to solve a big problem. You also have to be able to put the pieces back together. So another innovative thing we've done in our work here is develop what we call contest webs. Contest webs are kind of like supply chains or supply webs for physical products, but in this case, they're for creating intellectual products like proposals or plans for what to do about climate change. So in this case, in the case of a contest web, there's a family of related contests, some of which are about specific subproblems, and some of which are about how to put those solutions from the subproblems together into overall solutions for the whole problem. For instance, in Climate Collab, we have basic contests about things like generating electricity and transportation. And then we have higher-level integrated contests for how to put many of the ideas from those other contests together into national climate action plans for a whole country or global climate action plans for the whole world. Our hope is that this approach can help develop better solutions to what to do about the problem of global climate change and more support for those solutions than anything we would ever otherwise have done. We also believe that this same approach can be used for many other kinds of business and societal problems. So I'd like to leave with one thought about where this is heading in the long run. I think that as our world becomes more and more closely connected with many kinds of electronic communication, it will become more and more useful to view all the people and computers on our planet as a kind of single global brain. And perhaps our future as a species will depend on how well we're able to use our global collective intelligence to make choices that are not just smart, but also wise. Thank you all very much.
Thank you, Professor Lowe, or Professor Malone. As a reminder to our viewers, please type in your questions in the Q&A box on the right side of the screen. Please take a moment to make sure that you have selected all panelists before submitting your question. While you're doing that, I'd like to take just a quick moment to tell you about some of our upcoming MIT Sloan Alumni online events. On October 24th, Christina Chi from the class of 2013 will be speaking about entrepreneurship after MIT, how to utilize your alma mater to succeed. Then in December, Professor Stuart Madnick will join us to discuss what every manager should know about cybersecurity. You can register for these events on the MIT Sloan Alumni online website or stay tuned for future communications from our team with details. I'd also like to invite you to some upcoming in-person events. On October 6th, it's not too late to register. We're holding our first MIT Sloan Global Women's Conference in New York City. On November 29th, here on campus, we hope you will join us for the MIT Sloan Innovating Health Systems Conference. Please visit our MIT Sloan Alumni Events website to register for these events or to find more information on upcoming events near you. Okay, so let's move on to your questions. We'd like to start today's Q&A with some spotlight questions that were submitted during our registration process. Our first question you'll see here comes from Paul Green, SM88 in Boston, Massachusetts. He's wondering, If adding women to the team increases the productivity of the team, why aren't there venture capital companies that exploit the rampant sexism of Silicon Valley to their own economic benefit by being women-led?
So this is a great question, a very interesting one. In fact, it's one I've thought about before myself. If you believe that that women are at least as capable and competent as men, and that there are persistent biases against women in some companies, then maybe what you should do is keep it a secret, not tell anyone you believe that, and create your own company or change the company you're already with to treat women more equally and to take advantage of their capabilities better than people do today. And I think if we believe what we teach you in classes here at Sloan about economics and more or less efficient markets, then companies that are able to do that should, in fact, have a real economic benefit over companies that don't. So I think it's a very interesting question about whether that's perhaps a more effective way of dealing with inequalities, gender inequalities in the world today than by various kinds of regulation or other policies. I don't have a clear opinion about which is better, but I think we certainly should be considering using these market-like methods to deal with this, and people who do that successfully can realize a significant advantage from it. So, very interesting question.
Thank you. And then as a follow-up to that, before I move on to our next spotlight question, we had one come in live just now that says that this is from Shiva Venkatraman, and they write, in my organization, we did increase female hires and the ratio of ladies to men. And when that ratio was the highest, we had the highest level of organizational performance. And then the follow-up question there is, do you think there's a peak ratio? I think you mentioned a little bit about this earlier on.
Yeah, it's a very interesting question. I think our results aren't necessarily predictive of everything that will happen in all real-world groups, but in our research that I was describing earlier, we've done some analysis of many different experiments, which I didn't show to you today, but there seems to be an indication that the performance of the groups, at least in our experimental setup, increases with more women, almost all the way up to all women, but having groups of all women seem to be a little less high performance than those that were mostly women. Would that be true in all groups in the real world? It seems to me there are probably more factors that wouldn't make it as simple as that. But I think there's certainly interesting implications here about how to create the most effective, the smartest groups. And taking better advantage of women is certainly one way, women's abilities is certainly one way of doing that. I think another implication here is that it may be possible to measure the intelligence of groups and experiment with all kinds of things to increase the intelligence of groups and see which ones actually work and which ones don't.
Okay, great. Thank you. We'll move on to our next spotlight question. This question comes from David Noble. He's MBA 97 in Old Greenwich, Connecticut. David asks, what do you believe is the future of algorithmic decision-making in managing people and organizations?
So I think there's a great future for algorithmic decision-making in managing people and organizations. Just for example, I think it's now possible to get more and more data about how different people perform, about how different groups perform. You can imagine, for instance, doing studies like the ones I told you about a few minutes ago on an ongoing basis all the time in the functions of a group and of an organization, and seeing which kinds of groups, which kinds of people are most effective at which kinds of tasks, which kinds of management techniques work best, etc. So that's a way of doing studies about different kinds that you gather data about it. But then I think it's also possible to use the results of that data gathering to make some decisions automatically. For instance, rather than relying on people saying what they're interested in and managers deciding what they're going to make them do, You might have some ways where people can register their preferences and algorithms can measure their performance, and then the algorithms might do some of the assignments of different people to different tasks. That's just one of many possible examples for managing people. I think there are lots of other decisions that people make today that algorithms can in some cases make more effectively, and I think we'll see more and more examples of that.
Thank you. All right, so we'll move on to our last spotlight question, which comes from Richard Sides. He's SM72 in Marblehead, Massachusetts. He asks, will the improvements in AI supplant the need for intelligent workers, such as radiologists who read x-rays, technicians who do pathology reports, and so on?
Yes, so good. I was hoping a question like this would be coming right after the last one, because my answer to the last one said machines will be doing more of the things that people do today, and I think that's true. I think machines will do more and more of the kinds of things that are listed here and many other kinds of things that happen in organizations. What I don't think, however, is that means lots of jobs will be eliminated and gone forever. I think the history of technological improvements for hundreds of years has shown that every time new technologies eliminate jobs for some people, they eventually create more jobs for other people, at least as many as were eliminated. Now, that doesn't mean that some people's lives and careers won't be disrupted. It doesn't mean we shouldn't do something about the people whose lives and careers are disrupted. But it means that I think it's very likely that in the long run, more jobs will be created, at least as many jobs will be created as are eliminated, and that there will still be lots of things for people to do. One example I like of that, for instance, is the printing press. When the printing press was created hundreds of years ago, that eliminated some of the jobs for scribes who spent their days copying by hand books, because those books could now be copied much more cheaply on a printing press. But those printing presses, even though they eliminated some jobs that had existed, created vastly larger numbers of new jobs for people writing things that could now be distributed more widely, for editors, for publishers, for advertisers, for news reporters. All kinds of new jobs were created in ways that were made possible by the printing technology that eliminated a few previous jobs. And I think we're likely to see many more new knowledge-based and other jobs created when computers make some of the knowledge tasks cheaper and better.
Great, thank you. Okay, so we are going to move on to some of our live questions that are coming in. We've got one here from Dave Bodie, who says, when you add wise to smart, do you not also add a moral dimension to the collective thinking? How should that work? Think of the recent basketball scandals, lots of smart people, low morals.
I think that's a really good and interesting question, and I completely agree with the question. That I intentionally put that word wise at the end there to kind of raise, at least in a subtle way, some of these questions. I think being smart, you could say that means being good at accomplishing your goals, whatever your goals are. But you can have smart people doing bad things, which I don't think is good. I think any new technology like information technology, or even you could say like the technology of organizations, designing organizations in the first place is a kind of soft technology as opposed to a hard technology. Any new technology raises questions about how you want to use that technology. If you get better at achieving your goals, it raises questions about what are your goals in the first place? What should be your goals? What should you want? What should we have? Of course, I don't have answers to all those questions. Philosophers and spiritual teachers and many others for millennia have been talking about those questions. But I think it is important for us to think about those questions, perhaps more seriously as we become more powerful, and not to sweep them under the rug.
Thank you. Michael DeMarco has an interesting question, which he has submitted, which is, groups implement solutions as well as solve problems, and the factors that lead to success, such as social perceptiveness, may not be the same. What are your findings?
Well, we haven't specifically studied that question, but I can give you my expectations. I think that even implementing a solution often requires effective intelligence. Coming up with an idea to be implemented requires a kind of creativity and a kind of intelligence, that's true. But figuring out how to implement that idea can often require just as much creativity and just as much intelligence. So I think most of what we have talked about today applies to the implementation of ideas, not just to the creation of them.
Thank you. On a related note, I guess Mary Cross has submitted a question that says, what are the project management implications as we start to utilize diverse groups of people which are geographically dispersed and perhaps not even associated with each other outside of working on complex questions or projects?
So you're asking about project management implications for diverse groups and often geographically distributed groups.
That's correct. Yeah.
I think that the first point to be made is that the new technology makes that possible in a way that never was before. It's now possible to have widely distributed groups, people all over the world working closely together in ways that just were not possible before. That means you have at least the potential to bring together groups of people with different combinations of skills, people who may have the best skills of anyone in the world or in the company or the organization for what needs to be done. So I think the technology enables much richer kinds or much richer ways of doing this. Does the technology make it easier for people to work together when they have different cognitive styles or different cultural backgrounds, et cetera? I don't think the technology necessarily makes it easier. It doesn't necessarily make it harder either. I think when you have richer interactions on video as opposed to just typing things, that makes it easier to interact with people. With today's technology, there are still things you get from face-to-face meetings that you can't get from just being online. There's a certain kind of sensitivity to body language and a chance to go out to dinner together and things like that that you get face-to-face that you don't get with today's online meetings. I think over time, more and more of those things will be possible online. I've been talking for many years about the possibility of teledining, for instance, where you use very high fidelity video conferencing in restaurants or places like that where you can, I could be sitting in Boston and you could be sitting in Munich or Mexico City or Manila, and we could have a dinner together by video. So I think more and more things like that will make it possible for people to build the kind of personal relationships that help diverse teams function well together. And that technology will make it possible to do that in a way that isn't yet possible to do at a distance today.
It's really interesting to think about. I love that image of dining with someone remotely. We have a lot of questions coming in, so this is great. There seems to be a lot of interest. Brant Jones has submitted a question that asks, there are many tools in the market to facilitate online collaboration and communication. Have any of the providers of these solutions shown any interest in this kind of research? If so, can you share any information on that?
We've talked to a number of IT providers about the work on measuring collective intelligence. I can't point to any examples yet of implications or impacts it's had on products, but I think there's some very interesting possibilities for that. I think the second part of what I talked about today, the organizational design questions, those are things that a lot of companies are thinking about. I think there's still a huge amount of research to be done to understand what works best and to come up with innovative new ideas of things that can be done. And I think there's lots of opportunities to work with technology providers about that.
Okay, great. Circling back to women on teams, we have two questions that are somewhat related. Natalie Garner from the class of 2017, who's in New York, has submitted a question saying, have you considered how the percentage of women would lead to different levels of equality of participation? And the related question comes from Chris Karam, who says, what happens when the women in the group are not at the same level as the men? For example, in administrative or similarly support-focused roles?
So the first question is, what's the relationship between having women in a group and having more equal participation in a group? I don't remember the exact correlations here, but I believe there was a correlation directly of that groups with more women were more likely to have more equal participation. I don't know what kind of theory you'd like to use to explain that. Is it cultural? Is it biological? Who knows? But it's an interesting observation that I believe was true statistically in our data. And it also appears to be correlated with having more effective groups, at least in our data. Can you remind me about the second question?
Yes, so this is from Chris. What happens when the women in the group are not at the same level as the men? For example, in administrative roles.
Right. You could actually ask the question independent of gender. You could just say what happens when you have people in a group who are at different levels of hierarchy. How does that affect the group's functioning? I don't have a research-based answer for that. We haven't specifically studied that, but it certainly seems likely that would change the dynamics of things and might change the results of how smart the group is in different ways. So this is kind of an example of one of many kinds of questions that I think would be very interesting to study from a research perspective and to the degree it's possible in a more applied setting. There's all kinds of things you can imagine doing in a group to help make it smarter, and some will probably work and some won't. And so a very interesting question of which ones work and which ones don't.
Great, thank you. We're trying to get to as many of these as we can, so thanks to everyone who's submitting their questions. This next one comes from Tom Tippall. He says, do you think that higher group social perceptiveness leads to better conflict management? Does that lead to better problem solving?
It's a very interesting question. We don't have empirical evidence about that, at least not that we've done, and I don't know of offhand of other researchers who studied it particularly, but one would certainly speculate that it would, that if you are very bad at reading other people's thoughts and feelings, conflicts are more likely to escalate. You're likely to never even understand what they're thinking and feeling, and therefore you're less likely to find compromises that might be good for both of you. So I think that it's likely that it would lead to better conflict resolution. It's worth saying, though, that being socially perceptive or having high social intelligence isn't always a good thing from the point of view of people of outsiders. Just because you are good at perceiving what other people are thinking doesn't mean you're going to, or what they're thinking or feeling, doesn't mean you're necessarily going to act in ways that are good for them. Sociopaths, for instance, are often very good at reading other people's thoughts and feelings, but they use that knowledge not to do things that are good for the people, but to exploit them, to take advantage of them. So this is a skill that can be used for good or for ill.
Thank you. I think we'll try to fit in at least two more. This one comes from Terry Prieb. What does your experience suggest that the broad educational industry should focus on to better develop people's ability to contribute to collective intelligence?
Very interesting question. The obvious things are the cognitive skills needed to do the tasks that are being done. But the less obvious and more interesting thing is how can educational experiences improve people's ability to work together in groups. I think one obvious answer to that is just by giving people more practice. Old-fashioned education was all individual. It was about teaching each person to work by themselves and to get their own answers, and if you worked with someone else, that was cheating. I think one useful step in the right direction is something that's happened a lot at Sloan in recent years, and much more than when I came here over 30 years ago, and that is much more team-based work in classes. So I think just having opportunities to work together, you learn a lot of things, some fun and some not to learn. Some are fun to learn and some aren't, but I think they're all useful in building skills at working together in groups and learning how to divide tasks and share credit and all kinds of things like that. In some sense, an even deeper question is, can we teach this social intelligence, not just by giving people experience at working in groups, but can we give them better actual skills at reading people's emotions, like reading emotions in eyes or predicting how people are going to interact? Turns out there's conflicting evidence about that in the research literature. Some evidence suggests that it's very hard to change people's social perceptiveness as measured by the reading the mind and the eyes test. Other research suggests that it's very easy, that you can let people spend half an hour reading literary fiction like Jane Austen, for instance, and that increases their score on the reading the mind and the eyes test. So I don't think we know for sure, but I think a very interesting question is, are there ways of teaching the kind of social perceptiveness or social intelligence that we saw in our research was useful for creating smart groups? I think the answer is probably yes, but I don't think we know yet exactly how to do that.
Okay, great. I think we're going to just try to fit one more in, and I think, and this one's from Andre Gloria, he's an MBA 13. So in thinking about collective intelligence and bringing it back to your workplace, could you and would you design a recruitment tool based on the factors of collective intelligence you identified?
So you can mean recruiting to an organization or recruiting to a team. The answer for recruiting to a team is yes, we think there's a very promising line of work in that direction. One thing we've done a little bit of work on and would like to do more is how to help select the right combination of people for a team, how to get the right kinds of combinations of people with different levels of or different kinds of cognitive skills and cognitive styles and emotional skills and so forth. I think there's certainly ways of doing that. If we're talking about recruiting to a whole organization of hundreds or thousands of people, it's a little less clear exactly how to do it, but it seems to me quite likely that you could use the perspectives we've talked about in the call today to think about not only how to take a group of people you already have and help them be more collectively smart, but also how to select the right people to do that as well.
Thank you. That's all the time we have today. Professor Malone, thank you again for joining us here. It has been such a pleasure to host this event. I also want to thank all of our Sloan alumni and friends for joining us. To keep this conversation going over social media, please use the hashtag SloanieChat. We hope you will be able to join our future MIT Sloan alumni online events, which are made possible in part by the Sloan Annual Fund. As today's event comes to a close, we hope you will take a moment to complete the brief survey that will automatically pop up on your screen. Thank you for joining MIT Sloan Alumni Online.